Hey guys, Mr. B here, and in this video we're going to be going over the chapter 12.1 practice problems. So let's begin here with number 1. Now again, all these problems can be found, or the answers for these can be found usually in the slides, but I'm going to help you out anyway. So number 1, it says a force is defined as a blank or a blank that acts on an object. So again, this is directly from the notes here, but a force is defined as a push or a pull that acts on an object. So we can say a push or a pull, and let's again do this in red. There we go. Okay, so anytime there's a push or pull on an object, that's what we call a force. Number 2, true or false, a force can act to cause an object at rest to move, or it can accelerate an object that is already moving. So that is true, right? Forces cause objects that are not moving to begin moving, or it causes objects that are already moving to accelerate, either speed up, slow down, or change direction. Number 3, how can a force change the motion of an object that is already moving? So there's two types of forces, remember, that we talked about in this section. We have balanced forces and unbalanced forces. And whenever we have unbalanced forces, that will cause the motion of an object to change, and it will cause that motion to change by accelerating. And that means either speeding up, slowing down, or changing direction. Okay, so we're going to say something along those lines. So we can say a force can cause an object that is already moving to speed up, slow down, or change direction. Okay, because again, it will cause acceleration, which essentially is any of those things. All right, number 4, the overall force acting on an object after all the forces are combined is the blank. So this, again, was in the slides. This is called the net force, which is basically the resultant force of all the force vectors that we have added together. Number 5, how do balanced and unbalanced forces affect the motion of an object? So remember that, again, this is from the section, but balanced forces don't cause any change in motion. Wow, I cannot select on red here. There we go. Sorry. Balanced forces do not cause a change in motion. So if you have balanced forces on an object, whatever the object was doing, it will just continue to keep doing that. Whether it was sitting still, if it was in motion, it will just keep on doing exactly what it was doing. Unbalanced forces, however, will affect the motion of an object by changing its motion, either, again, causing it to slow down, speed up, or change direction. So we'll say balanced forces cause the motion of an object to not change. We'll say unbalanced forces cause the motion of an object to change by causing the object to accelerate. Okay, something along those lines. All right. Number 6, true or false? Friction is a force that helps objects that are touching move past each other more easily. No. Remember that friction is a force that is always trying to oppose the motion of an object. So friction is essentially always trying to cause objects to stop moving. It doesn't help, it makes it harder, right? So this is definitely false. It does not make things easier when they're moving past each other. It makes things more difficult. Number 7, circle the letters, say the letters, that identify types of friction. So there was 3 types of friction that we talked about in this section. There is static friction, sliding friction, rolling friction, and I guess, sorry, there's 4. Fluid friction. But of the choices here, that is not a choice. So rolling friction, that is one type. Static friction, that is another type. And then sliding friction is the third type. And gravity, although gravity is a force, it is not a type of friction. Okay, so it's not a type of friction, it's just a force that we have on us all the time. Number 8, the friction force that acts on objects that are at rest is, so this is called static friction. This is the type of friction that is acting on objects that are not moving. Okay, remember the word static means non-moving or non-changing. It doesn't mean like electricity, even though we typically think of a static electricity when you hear the word static. Number 9, why is less force needed to keep an object moving than to start the object in motion? So one of the things that was mentioned when we went through the notes was how strong different types of friction are. So static friction is the strongest type of friction, then sliding friction is weaker than that, and rolling friction is even weaker. So because static friction is the strongest, it takes more force to get an object moving by overcoming the static friction. But once the object is moving, then the friction is going to be either sliding friction or rolling friction, both of which are weaker than static friction. So it's easier to keep the object moving once it is moving than to get it started moving in the first place. Okay, so we're going to write down an answer that basically summarizes that. So we'll say static friction is the strongest type of friction, whereas rolling and sliding friction are weaker. Therefore, it is easier to keep an object in motion than it is to get an object to begin moving in the first place. Okay. Number 10, gravity is a blank force that pulls objects together. I think the word we're looking for here is an attractive force. Okay, so gravity is an attractive force that pulls objects together. So let's go attractive. Number 11, true or false? Earth's gravity acts downward toward the center of Earth. That is true. Okay, gravity is always acting downwards. It does not act at an angle. So again, what this means is that gravity is always going to be pulling straight down. Even if an object is going down a ramp, right, and it's going down at a diagonal angle, gravity is still pulling it straight down, even though the object's sliding this way. Gravity, the force of gravity is still straight downwards. Number 12, true or false? Terminal velocity is the constant velocity of a falling object when the force of air resistance equals the force of gravity. That is true. Okay, so terminal velocity is a constant velocity, meaning that you're not accelerating anymore. You're not speeding up, you're not slowing down. And it occurs when the force of gravity pulling downwards equals the force of air resistance pushing upwards, and those two forces essentially cancel each other out, and you get a net force of 0, which means you're not speeding up anymore, you're not slowing down anymore, you're just traveling at the same speed the whole time. All right, last one, number 13, the curved path caused, I think I should say caused, the curved path caused by the combination of an initial forward velocity and the downward force of gravity is known as blank motion. This is called projectile motion. So you have an initial forward push, and then gravity starts to pull the object downwards, and you get a curve, okay, that happens like this. So again, this is what we call projectile motion. All right. Oh, almost had it. We'll get there. Projectile motion. Perfect. All right, so that is it for this section notes and all those practice problems. Hopefully that helped you and gave you a little bit of clarity. But again, as always, if you have any questions, feel free to reach out to me so that I can help you. All right, guys, thanks for sticking with me. I'm Mr. B, and I'll see you in the next one. Bye.